If you're asked to predict the products from a single displacement reaction, how do you do it? Step 1, figure out whether or not the element that you're given will replace the metal in the actual compound. Here we're asking, will magnesium replace copper? To figure that out, you need something called the activity series. This is probably a chart that your teacher gave you, or it's in your textbook. What it is a list of a whole bunch of different metals from most reactive to least reactive. The higher an element is in this list, the more it'll replace other elements. Put another way, magnesium will replace copper if it's higher in the list. Well, I see magnesium here and copper way down here. Magnesium is more reactive, and so it will replace copper. So we will have a reaction. If magnesium had been lower, we would have just said no reaction. Like that would have been our answer, and we'd be done. But it does replace it, so we got to keep going. The new question is, what ions are now paired? Well, let's see. Magnesium is going to replace the copper, and the copper is going to get booted out. So, first of all, you're going to end up with copper left over. Then, how does magnesium bond to fluorine? This is where you need to know your ions. Magnesium is in the second column of the periodic table. See, it's right there. You guys can't see that. It's right here. Magnesium loves to form the ion 2+ because it wants to lose 2 electrons. Fluorine wants to gain 1 electron. It usually has a charge of -1. And to actually figure out what the compound is, you have to crisscross those charges. At least that's what a lot of teachers like to call it. And you're left with Mg1 F2. Notice I didn't write the little subscript 1 because that's just convention. So, if you put solid magnesium in a solution of copper fluoride, the magnesium would replace the copper and you'd end up with solid copper and magnesium fluoride. It's kind of a cool reaction. Now, you could be asked to do this for several other reactions. Let's see what we can do as quick as we can. Silver plus sodium chloride. Will silver replace sodium? According to my chart, silver's down here, sodium's up here. Silver is lower, so silver will not replace sodium. We're done. No reaction. Will calcium replace tin? Now let's take a look. Calcium is way up here. Tin is way down here. Yes, it will, because it's higher in the list. When calcium boots the tin out, you're going to end up with tin by itself, and calcium, which is usually 2+, bonding with nitrate, which is usually 1-. Crisscross your charges, you end up with Ca1 NO3 2. Done. Will aluminum replace copper? Aluminum's up here, copper's down here. Yes, it will. Aluminum boots out the copper. The copper is all by itself now, and aluminum's bonded with sulfate. Aluminum is 3+, sulfate is 2-. Crisscross. Al2 SO4 3. Done. Will sodium replace hydrogen? Well, sodium is way up here, hydrogen's way down here, so yes, it will. Now, I've included this one because it's an exception. It's a little bit tricky. Sodium will replace hydrogen, but it doesn't replace both hydrogens in water. Just watch out. This only really happens for water. You need to consider water to be like hydrogen hydroxide. HOH. See, there's still two H's, there's one O. This is just another way of writing it. The sodium really only boots out one of the H's. So, you'll end up with hydrogen by itself. Hydrogen by itself is H2. It's one of those atoms that makes, what do they call them? Diatomic molecules. There's two atoms in each of the molecules. And sodium is now bonded to hydroxide. Well, sodium is +1, hydroxide is -1. Crisscross, and you get NaOH. Watch out. You don't get Na2O. There's an H left over because the sodium only boots out one of the H's from the water. Best of luck in solving your own single displacement reactions.